All right, now it's going to get fun. There are many FA volume questions pertaining to the displacement of an engine. Displacement is defined as the amount of fluid a piston would push out of the cylinder when piston is moved from bottom dead center to top dead center, TDC. So in other words, you take the piston, you bring it all the way to the bottom of the cylinder. And don't ask me what happens with the horizontal opposed engine that's sideways. They put it this way. Put them this way, and it's theoretical. You fill it full of a fluid with the piston all the way to the bottom, and then you push the piston up, and the fluid comes out, and you put it in a cup, and you go, oh, that's the displacement. That's how you do it. We don't do it that way here in the class with the FA test questions. It's all theoretical based upon measurements and cubic inches. So let's see. In other words, that's the displacement of one cylinder. So then you have to figure out what is the displacement of how many cylinders there are in the engine. So the first question that, for whatever reason, I tended to copy and write down here is a terrible question. And it says a four-cylinder engine, I'm going to abbreviate, so I have to write, a four-cylinder aircraft engine has a cylinder bore of 3.78 inches. And what is bore synonymous with? What does bore mean?
Diameter.
Bore equals diameter. So we just have to remember that. Bore equals diameter. Bore equals diameter. All right, back to this. A bore of 3.78 inches, and this is where we would never talk like this, but the question does this, and is 8.5 inches deep. I don't even know what the hell that means. Inches deep. We don't talk about, deep. That just worked out great. Stupid thing's locked up. There, thank you. Deep, period. With the piston on bottom center, 85 deep with, I don't think the period should have been there, with piston at bottom dead center. Hang on, that is period. Let's try it. With the piston at bottom dead center, the top of the piston, measures 4 inches. It doesn't get worse than this. So measures 4 inches from the bottom of the cylinder. From bottom of cylinder. What is the displacement? All right, so let's just draw this out. Just kind of go, what are you talking about? So here's the top of the cylinder. And we're going to need to know two things. One, we need to know the area of the piston, And two, we need to know the stroke. Well, and three, number of pistons or cylinders. Number of cylinders. That's all we need to know. All the time. Just don't do that. So first of all, area of the piston. We can work that. Area of the piston. So I have area of a circle, because a piston is round, equals pi times radius squared. And since I have a bore of 3.78 inches, what is my radius?
1.89.
So the bore is, where does it go? Oops, change my page. 3.75, bore is 3.75. So that means the radius equals half of that. So it's what again? 1.89. 1.89. So back over here, so that's area equals pi times 1.89 squared. So the area equals, work it out on your calculator, 11.22 inches squared. Okay, that's the area. Next, we need to know the stroke. Normally, most of the questions say, and the stroke is 4 inches or 3 inches, and then you're done. But this one had to give the most asinine way of finding something that I have to stop and figure out. So, see the stroke. The stroke is, we had 8.5 inches deep. So let's see, 8.5 inches deep, 8.5 inches deep, and we never talk like that. With the piston at bottom sitting, the top of the piston measures 4 inches from the top of the cylinder. So with the piston on bottom dead center, so I'll just draw the piston down here. Here's my piston. With the piston on bottom dead center, the top of the piston, right here, measures 4 inches from the bottom of the cylinder. Oh, okay, here's the bottom of the cylinder. So bottom of the cylinder from here to here is 4 inches. Therefore, the stroke, in theory, is 4.5. Well, assuming it goes up and smacks the top of the head, which it wouldn't. That's all the information they give you. Therefore, what's left over is 4.5. Everybody follow me? All right, so that is my stroke. And again, this is the worst of them all. So the stroke equals 4. Area of the piston equals 11.22. So it is the area of the piston, 11.22, times the what? Stroke, which is 4.5 equals 50.49. And that is what? That is the the displacement or the cubic inches of one cylinder. So cubic inches of one cylinder. How many cylinders were there? 4. So multiply it by 4.
201.96.
201.96 inches cubic inches total of that engine. And again, that's the worst one. So, all right, how about this one? A 6-cylinder engine. 6-cylinder engine with a bore of 3.5 inches, a cylinder height of 7 inches, and a stroke of 4.5 inches. We'll have a total piston displacement of, what is my displacement? See if you can get that one. I will work silently. Did you get 259.77?
Yes, sir.
All right. What'd you do with this 7 cylinder height right here, 7?
Ignored it.
Just ignore it. It is nothing, and it doesn't. It's like, would you give that to me for? Boogeyman number? Red herring? All right. Got that. What is the piston displacement of a master cylinder with a 1.5 inch diameter bore? They're nice to give you both diameter bore, and a stroke of 4 inches. So area equals pi radius squared. Area equals 0.75 squared. Now, what'd you get?
7.065.
0.65. All right. We either all did it wrong together, or you guys are fantastic. Let's see. Just going through this so fast. 20.
For that previous question with the cylinder height at 7 inches,
Yep.
could you have used that to find the compression ratio of that cylinder?
Nope. Because they didn't tell you the difference between what the volume was on top. You had no idea. So there was not enough information to even figure out what it was. Because you don't know where the piston starts and stops. They left you hanging. All right. What is the displacement of the following engine? Let's see. We have a 4-cylinder engine. With an original cylinder bore of 5.125 inches. But as part of a rebuild, the cylinders were bored oversized by 0.020 inches. And it has a stroke of 3.875 inches. So what does that mean for those of you? We can work this together at least to start. What is the bore going to be?
It's going to be 5.125 plus 0.020.
125 plus 0.020. It was bored oversized. So oversized. They literally put it on a machine with stones, and it'll either grind it in a circle or up and down and around, and you actually enlarge it and take away material until it's 0.020 larger than it used to be. So you get some big horsepower out of it now.
Just with that little amount of horse.
No.
Well, if it had torque compression before, then you can get some more.
Yeah, of course, yes. You fix some other problems along with it, yes.
Times 4. It's a 6 or 4.
Oh, it's 4-cylinder. $322.25.
Yes, sir.
Okay. Yep, everybody's good? Anybody bad? All right. One last one on cylinders here. The volume of a cylinder. The volume of a cylinder with the piston at bottom dead center, BDC, is 84 inches cubic. And the piston displacement is 70 cubic inches. So, and the displacement is 70 cubic inches. What is the compression ratio? We can kind of work this one together for those who need help. So it is a difference between two things. What are the two things it's a difference of?
Volume, top dead center.
Volume at top dead center, that little space up there, little tiny space, versus
Volume at bottom dead center.
all the volume at the bottom dead center. So what are we going to do here?
We're gonna subtract 70 from 84.
So bottom dead center equals 84. And then, let me think, top dead center, what do we got? Oh, we displace 70. So, not top, but we displace 70, so we'd minus the displacement of 70. So, have all this volume, we displace, we're trying to figure this space out. So, total we have 84, but it pushes out 70, so what's left over? 14. So, I have 14 left over. So, if we have 14 left over, that's the space here. What's the space here?
84.
So what's my ratio?
6 to 1.
Improper fraction, 84 and 14 equals
6 to 1.
6. So 6 to 1.
Would you call that like headspace or not really headspace, but what would you call that upper?
I call that little space left up here.
Yeah.
That's what I call
Okay.
it.
Pretty scientific.
This is, yeah. I didn't mean to get all technical on you on your first week, but I'm sorry for doing that. But all right, compression ratio 6 to 1. All right, that's enough of that. Let's talk about binary numbers. Binary. All right, binary numbers. As a mechanic, let me tell you how many times I had to deal with binary numbers. That would be 0. Or it's on the FA test. And it took me a very long time. I always had the worst time with these new switches because I could never figure out which one was on and which one was off because they both had an O and an I. And I never knew what the hell the I stood for. Then one day it occurred to me, it's not an I, it's a 1. 1 is on and 0 is off. And my life got easier from that point on. Otherwise, I was just doing this. Does it work now? Because I didn't know. You know, it's like this switch here. See, that's got one, you know. Oh, that one says on off. But otherwise, it's like, I don't know. I got to find something to plug it. Get my wife's hairdryer and plug it in and see which one. All right, so 1 is on and 0 is off. And that's what binary numbers has to deal with. And in a minute, if you don't know anything about binary numbers, in a minute you will get that there are 10 types of people, those who understand binary and those who don't. Now you're like, I don't get it. In a minute you will. I'm like, oh, that's kind of clever. Not my joke, but okay. So binary. Binary. I think this is a test question, so I had to write it down. A byte. A byte is defined as a group of bits representing a complete piece of information. And like I said, I think that was a test question. All right, so binary uses only 2 digits. And those digits are
1 and 0.
1 and 0. Based on the fact that switches are either, based on the fact based on the fact switches are either on, which is a 1, or off, which is a 0. And I'll say it's based on the powers of 2. Powers of 2. And to do binary, the first thing I like to do is create a grid. So if I'm actually working on a problem, I'm going to make a grid, and I start on the opposite side. That's the hard part, is remember, on the opposite side. I start with 1. And 1 times 2 is?
2.
2 times 2 is?
4.
4 times 2 is?
8.
8 times 2 is?
16.
16 times 2 is?
32.
32 times 2 is?
64.
And 64 times 2 is?
128.
And that's all the further you need to go with this. So take my scratch paper, and I'm going to do that. And then based upon that, you can figure out exactly what you need to do. So for example, then I would put like 128, I would put like 1 or 0, which is the same as yes or no, if you like. You don't have to write all this. So solving an 8-bit binary number. So if I had a number that was, my number is 10110011. That is the number in binary. And what you do is you fill this in the chart. Assuming you have all of the numbers, then each one is going to take a place. You can just start right here. And it's 1, 0, 1, 1, 0, 0, 1, 1. And of course, a 1 is going to be yes. And you don't have to put this, I wouldn't do this on a test. And 2 is no, that's yes, yes, no, no, yes, yes, whatever, it doesn't matter. All right. Then we can bring down the number values. So if we have a 128, we're going to give ourselves 128. We have a 64, nope. 32, yes, 32, 16, 8, no, 4, no, 2 is yes, so we get a 2 and then a 1. And then we just add it all up. So 128 plus 32 plus 16 plus 0 plus 0 plus 2 plus 1 equals?
179.
That number is 179 in binary.
Wow, that's great. So what is there sometimes, do they group binary always in 8s? Is there something about that, or is it like,
That is
is it just
byte.
kind of like,
It's an 8-bit binary, right?
Yeah.
Yeah.
so it goes for
Yeah.
you're saying we only needed up to 100.
That's all you need is 8-bit. That's all you're going to be asked about. All right. So what about the number 00101111? I know. I moved the grid, huh? Start over here. Start with 1. Start with 1. There you go. 1, 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16. And this one? 1, 2, 4, 8. What's that?
You got 7 there.
Yeah, it's a 7 binary.
I think my pen is screwing up on me a little bit. 0, 0, 1, 0. Yeah, I just did that.
Okay.
I didn't write.
Thank you.
Oh, you put another 1 in there?
Yeah, I actually tried. It just didn't want to do it with me. I heard it. 47. How about this number? 111. 4 ones. Of course, now you just have to know which way to start. What's that? It's going to be all the way on the one side. So it's implied that there's zeros here.
Oh.
So it's going to go 1, 2, 3, 4.
Oh wow, that's confusing.
It is a little bit. So how much is that? It's 8 plus 4 plus 2 plus 1, which equals? 15. All right. Okay, what about going the other? Yes.
So you can't go more than, oh wait, no.
Well, since you brought it up, what's the highest number we could possibly go to?
1.
Say 2048.
No. It'd be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which is 255.
Oh, because if you go 256, it's.
If you get 256, you've just gone over the maximum amount.
And it rolls over back to 0.
Negative.
Well, you'd have to go to the next size binary. So in a, what?
In an 8-bit system, we would go into a stack overflow, so I think negative.
Stack overflow. Come on, man.
Oh yeah.
That's silly. Yes,
God, man, he has the dumbest questions, honestly. Everybody knows stack overflow. All right. Okay, what about converting back out? So what if we wanted to convert 233 to binary? Let's put a line right there and keep my kind of chart here. All right, so we start at the beginning, and I say 233, does 128 go into 233? Yes, so we put it right there, so that's 1. So I like to have my calculator out, and I say 233 then minus 128 equals? Minus 128 equals 105. So can I have a 64 in there?
Yes.
Yes, so then it's 105 minus 64 equals 41. So can I have a 32? Yep, so 41 minus 32 equals 9. So can I have a 16?
No.
Nope. Can I have an 8?
Yep.
Yep, so 8 gets a 1. So I have 9 minus 8 equals 1. So can I have a 4?
No.
Have a 2?
No.
Can I have that? So yes, so 233 equals 111,01001. What about the number 7?
111.
421 or 000000111.
Yeah, except I'm crashing my program here. Very angry with me. So 128, no. 64, no. 32, no. 16, no. That was number 7? No. 4?
Yep.
Yes. Yes.
Yep.
Yes.
111.
So 111 is a n number. And then I ask, what is the largest 8-bit binary number we can get? And I already told you that. 255. All right. That was so easy.
Crazy. I feel like I could build a computer now.
We know about Stack Overflow. And
Probably know the largest number.
tell you what I know about Stack Overflow. That's when my wife orders a bunch of stuff from Amazon and the guy delivers everything. I got Stack Overflow. It just happened
Yeah.
right there.
I was gonna watch The Matrix tonight and be like, I don't know what that means.
Okay, let's revisit this a little bit. So we are going to be doing a lot of stuff in here, especially with milli. And I want to make sure that in kilos, so that you're very familiar with Milos. My son's dog who's living with me is Milo, so I just can, he's small, so Milo. All right, so we have all of our prefixes, and I kind of ran across something the other day that I was kind of cool. So we have units. So if we go, we'll do 10 to the negative 3, 10 to the negative 6, 10 to the negative, we'll just go by 3s, 9, and 10 to the negative 12. Then going positive, we have 10 to the 3rd, 10 to the 6, 10 to the 9, and 10 to the 12. And I think this would be kind of a neat chart to have handy because it can kind of help you. So, of course, this would be 10 to the 0 right here. 10 to the 0, it's just normal. What is our name for 10 to the negative 3?
Millie?
Milli. And what is my letter?
Lowercase m.
Little m. All right. By the way, you cannot do this. You cannot have, like, if I had 1,000, scientific notation, that looks like what?
1
1K.
times 10 to the third.
Times 10 to the third. I can't put times 10 to the third k, can I?
No.
No, because that's like saying 1,000k, I guess. That's a whole different number. This means times 10 to the 3, and this means times 10 to the 3. So that'd be like 1.0 times 10 to the third times 10 to the third. That, you can't write that, right? That's no good. Either pick the 10 to the third or pick the k when it's appropriate and stick with it. All right, going this way, we have kilo. Kilo's this one, right?
Yep.
Kilo. A lot of you guys know keys. And what is my designator, my abbreviation? Lowercase k. Why is it lowercase?
Capital case Kelvin.
Capitals Kelvin. All right, this one times 10 to the 6th is
Mega.
mega. Mega is a
Capital M.
capital M. This one is, I don't really use this one in class ever, but giga. Giga, which is
Lowercase g?
big G.
Oh, it is.
And this one is tera. Again, I don't use that one. Tera, which is T. All right, so going back this way, we have 10 to the negative 6, which is
Micro.
micro. M-I-C-R-O, which is
U.
an even littler m. No? It's a cursive, yeah, it's the Greek letter M, mu,
Mu.
which is kind of a cursive U. All right? Huh? Then after that, and I don't really use this, so I definitely in class will use this one, and this one. Very rarely would I use mega. It may come up once or twice, but I don't typically. And I don't use this one right here, really, but nano,
Nano.
which is little n. But I will use this one, pico. Like pico de gallo. It's small de gallo. That's what that means.
Picoseconds.
Yeah, that too. Which is little letter P, and I don't think it's called. That's not pico de gallo. It's not correct. Let's see. What was I thinking about here? So anyway, these are the units right here, and like I said, this is kind of something nice to have handy. This also works well for converting. How many decimal places you can move things. Like if you want to go from micro to milli, it's 3 decimal places. From micro to kilo, it'd be 3, 6, 9 decimal places. So it can help you convert stuff back and forth if that helps you. But we definitely want to commit each one of those to memory and how they work. But we covered a lot of that in 309, and I think you guys are doing pretty well with that. Just make sure that you don't convert. Yes?
Do you like not normally use like nano and giga and all those in the field?
I definitely didn't because of what I did, which was work in general aviation and build aircraft and carburetors and magnetos and things like that. Pico would come up just because you'd say it. Well, that's a, because in capacitors they're usually pico, farads, but that's about it. So it didn't for me. And so it just so happens that the numbers that we're using in this class, the way the FA textbooks are written and the questions, it really just doesn't come up much. I've never seen nano come up, so I don't use it. But I certainly use a milli, micro, and to a large extent in here, and kilo, because our resistors are in k ohms, a lot of them. And that's why. So, all right, you guys feeling good?
Yes, sir.
All right. I don't know. I think I want you fresh for this next one. I'm wearing you out. So, all right, questions?